So just a quick warm up. If we go back to what we know, if I notice this is an isosceles triangle, I'm looking at this first triangle here. So this triangle right here, it's an isosceles triangle. I can tell because it's marked. So that means that if this angle is 45, that this angle also has to be 45 because the angles across from the two congruent sides have to be congruent. So that's also 45. If those two add together to be 90, that means this angle has to be 90, which means that it's a right angle. So the benefit to what we just did is now we know that this is a right triangle, which enables us in some cases to do Pythagorean theorem. So if I label everything, so I've got all my angles labeled, and I know that if this side is 3, then this side has to be 3 also. So if I go in, and now that I know 2 of the sides, if I want to know the third side, I can use Pythagorean theorem. So I can use a squared plus b squared is equal to c squared. So I have 9 plus 9 is equal to y squared, or y squared is 18. And remember, we go in, we take the square root of both sides. I'm going to simplify that square root of 18. It's 2 and 9. Now I notice that 9 is a perfect square, so I'm going to stop right there. Square root of 2 and the square root of 9. Square root of 9 is 3. The square root of 2 is 2. So my side lengths are 3 and 3 and 3 root 2. My two sides that are my two legs are 3 and 3, and my long side, my hypotenuse, is root 2. So I notice the same thing here. I have an isosceles right triangle because this is 45 also, and this is 90. There are a lot of different ways that I can tell you that a triangle is a 45, 45, 90 triangle. Okay, which is what we're focusing on today is 45 special, they're called special right triangles because they have certain relationships. We're going to talk about 2 different kinds, 45, 45, 90 today, and then 30, 60, 90 another day. But they always have these special relationships, these ratios between the sides. So again, I know that my sides are congruent, so these 2 are 2. If I use what I know about Pythagorean theorem to find that third side, that hypotenuse, 4 plus 4 is 8. If I take the square root of both sides, then if I simplify that square root of 8, I get 2 and 4. 4 is, the square root of 4 is 2, and then the square root of 2, right? So this 4 gave me that, just a quick reminder, and then this root 2 gave me that. So y is 2 root 2. So those numbers are 2 and 2 and 2 root 2. So you see a pattern that when the legs are the same, that it's always the same number with a root 2. So that is one of the things that sets up special right triangles. And this is on your formula chart where it'll be that a 45, 45, 90 triangle has these special ratios. Every 45, 45, 90 triangle is going to follow this same pattern. And what it's going to be is that it's going to be some multiplier where this side, if this is 45 and this is 45, so if I have a 45, 45, 90 triangle, my 2 legs are going to be x. So they're going to be the same length. And my hypotenuse is always going to be the length of the leg times the square root of 2. Always. Now, sometimes the square root of 2 is going to be built in. I'll explain what I mean by that in a minute. So it's not always actually going to have a square root of 2 on the hypotenuse. But it's always going to be, whatever the value is, it's always going to be x times the square root of 2. So I'll show you, this is where some of those multiplying and dividing radicals is going to come in to what we did earlier in the lessons. So here's what I want you to do. This right here is extremely important. You're going to want to bubble it, star it, you're going to want to highlight it. This is extremely, extremely important. In particular, these right here, x, x, and x root 2. Notice where they are. The x's are always across from the 45s, and the x root 2 is always on the longest side, which is the hypotenuse. So here's what we're going to do every single time. The first thing that we're going to do is we're going to label our sides. Okay, we're going to label our sides with x, x, and x root 2. Okay, X equals, and x root 2 equals. That's what we're going to do. Okay, so let's do that. So our hypotenuse always gets the x root 2, so I find that. So C equals x root 2. 4 equals x, and 4 equals x. You could also do x is equal to 4 if you want to. In fact, let's do that. Let's go ahead. Now, I know that in your notes, you may have an x there. That's okay. I want you to change it to a c, because if we use x, and x root 2, I didn't think about it when I was writing the notes, and I put an x and a y there. So if you have an x and a y, just replace them with the letters that I have here. Okay, so we have x is equal to 4, x is equal to 4, and x root 2 is equal to c. Okay, so that's what we have. So the first thing you want to do is you want to label your sides. And then you want to, you're going to notice that there is an equation that already has a number. So you're going to solve the equation that comes up. Okay, so if you look, we've got an x is equal to 4 and an x is equal to 4. That's what you want to look for. And then we've got x root 2 is equal to c. Now that's an equation, but there's not enough that I can solve for that. Okay, so here's what we know then. X is equal to 4. Well, if x is equal to 4, and if c is x root 2, right, that's what we have right here, x root 2 is equal to c. Well, I just said that the x was 4. So basically, here's what I do. I just replace that 4, or that x, like literally, I can go in here and I can erase it, erase that x and replace it with a 4. So c is 4 root 2. 4, 4, 4 root 2. See how it follows that same pattern where your legs are the same and your hypotenuse is the length of the leg times root 2. So let's look at B. Again, label your sides. So actually we labeled our sides, we solved our equation, and then we found the leftovers. We found what was left. Okay, so we found our other sides. Okay, so we do the same thing. Label our sides. I notice this is 45, 45, 90. Later on, that's going to be important. I can tell it's 45, 45, 90 because the sides are the same. So I have x is equal to, and x root 2 is equal to. Well, here's your equation. This is the one that you have to solve because it's the one with the number. Find the one with the number other than the root 2. So set that up. X root 2 is equal to 20 times root 2. So what we want to do is we want to solve for x. Well, it's x times root 2. Now, just think, what would you do if that was 2x? You would divide by 2. So it's not going to do any different just because it's a root 2. It's okay. You just divide. So root 2 cancels root 2. This root 2 cancels that root 2. And that means that x is 20. Well, if a is x, then a must be 20. And if b is x, then b must be 20. So we have a 20, 20, 20 root 2 triangle. Sorry, I keep shifting around and it's turning it. Now, this one's a little different. Notice you have the hypotenuse, and notice that there's not a square root of 2 on that hypotenuse. That's okay. This is how we're going to do it. We're going to just keep following our same procedure. You put your x is equal to on your legs, and you put your x root 2 is equal to on your hypotenuse, to whatever is already there. Okay, so we can't solve x is equal to a or x is equal to b, so we have to solve x root 2 is equal to 20. So I need to get x by itself, so I'm going to divide by the square root of 2, divide by the square root of 2. Okay, notice your root 2's cancel here. Now, here's where understanding that shortcut that we did the other day would be helpful. So I'll talk about the shortcut. So we do x is equal to, now it's 20 divided by 2, so 2 goes into 20 10 times, but I didn't actually divide by 2, I actually divided by a square root of 2, so I'm going to tack a root 2 on it to it for the end. Okay, now remember actually what we did the other day was we're not allowed to leave, x is equal to 20 over root 2, but we're not allowed to leave radicals in the bottom, so we have to multiply by root 2 over root 2. So we ended up with 20 root 2 over, remember, root 2 times root 2 is 2, and then the 20 and the 2 cancel out to give you 10, and you end up with 10 root 2. So you can get there either direction, whichever way makes the most sense to you, okay? So look at those, look over those, try these next ones, put this on pause, and then come back and try them. Now, for some of them, we like the 45, 45, 90s because they're easier to see. Things will get a little more complicated when we get to 30, 60, 90s, but it's going to be the exact same process, just with different numbers. So once you see the pattern, then you'll be able to go through some of these pretty quickly. But you can always follow your steps. Okay, so put me on pause if you need to. Go work these problems and see if you can. Okay, so hopefully you work the problems. So again, label your sides. This is a 45, 45, 90 triangle. So I'm going to say x is equal to, well, x is equal to 42, and x root 2 is equal to c. Now the only one that has a number where we can solve it that doesn't have two variables is the x is equal to 42. So if we know that x is equal to 42 and x is equal to a, well then that means a must be 42 also. And if c is x root 2 and x is 42, then c must be 42 root 2. Because we literally replaced this x. Everywhere there's an x, we just replaced it with a 42. We just rewrote it with a 42. Okay, we'll do the same thing here. We've got x is equal to a, x is equal to b, x is equal to 15 root 2. Well, there's no equation to solve. We already have x is equal to 15 root 2. Oops, x root 2. I did something wrong. I'm sorry. I'm going to write it over here for space. X root 2. I forgot. X root 2 goes on the hypotenuse. See, you can make mistakes just like me. Okay, sorry about that. So that's the equation we have to solve. So we have 15 root 2 is equal to x root 2. So I'm going to divide both sides by the square root of 2 so that I can get my x by itself. Do you see we keep doing the same things over and over? That's what's nice about these problems. With practice, you'll just get really good and used to them. So all the root 2's cancel out, and you're left with x is equal to 15. Well, if x is equal to 15 and x is equal to a, then a must be 15. And b is equal to x, so b must also be 15. So I have a 15, 15, 15 root 2 triangle. Okay? Now, some of you might be able to look at 3 and just go instantly. You know exactly what it is. It's 5, 5, and then c is the hypotenuse, so it must be 5 root 2. But if you don't see that, that's perfectly fine. Okay? Just keep doing what you've been doing. X is equal to, x is equal to, x root 2 is equal to. Well, the only one we have, x is equal to 5, we've already got. Well, if x is equal to 5 and c is x root 2, then literally you just change that x into a 5 because it says x is 5. So c is 5 root 2. So if you didn't get it before, you would get it here. Okay, 45, 45, 90, x is equal to a, x is equal to b, and I'm going to write it on this side because I have more room. X 24 is equal to x root 2. X root 2 always goes on the hypotenuse. So that's the equation we need to solve. So I'm going to divide by the square root of 2. Again, this is where it's nice to have that little shortcut. 24 divided by 2 is 12. I divided by the square root of 2, so I'm going to tack a root 2 on the end of it. Or if you need to, right, you can root 2, root 2. You have 24 root 2 over 2, which cancels to 12 root 2. It's just nice to have, if you can just remember that little shortcut every time, as long as the numerator is a whole number and the bottom is the radical, it'll always work. So x is 12 root 2. Well, a is x, so a is 12 root 2. And b is x, so b is 12 root 2. So see, we still have, it's still that same pattern, same, something times root 2. It's just now it's 12 root 2, 12 root 2, 24. So that's what I was talking about with it being built in. That 24 has the root, it has the root 2, it's just built in so you can't see it. But it does still have a root 2 in it. It's just not written, so you can't see it. But the length of that side is 24, and the length of the two legs now is 12 root 2. So 5's kind of a little bonus one. It's a little bit harder because of that root 3 in there, but it's okay. It's not too bad. So let's look. We're going to follow the same rules. Be careful. You've got your x is equal to here. This is x is equal to also, and this is x root 2 is equal to. So your hypotenuse, always find that hypotenuse. Label it with an H if you need to, okay? So we can see right here that we already have our equation. It's already solved. We don't need to solve for it. So I've got x is equal to a, x root 2 is equal to c, and x is equal to 2 root 3. So since x is equal to a and x is 2 root 3, I'm going to replace that x with a 2 root 3, so a is 2 root 3. And if x root 2 is equal to c, I'm going to replace that x with a 2 root 3. So I've got 2 root 3 times root 2, right? It was x root 2. Well, remember how to multiply. You can multiply them together if they're both underneath, and you can multiply them together if they're both outside. So I have a 2 outside, so it's 2, and then root 3 times root 2, which is root 6. So c is 2 root 6. So you don't have to do anything. You don't even have to really remember anything except for where to put the x, and the x root 2. And then how to solve the equation. And then it's just little things like how to multiply and how to divide the radicals. But then once you find out what x is, you're just substituting it back in. Okay, it all comes back to knowing these numbers and where to put them. You've got an x and your x that are across from your 45, and your x root 2, which is on your longest side, which is your hypotenuse. Set up your equations, label your sides, set up the equations, and then use that x to find your other sides.